Good morning, everyone. Okay, so we just did percent of increase decrease 2 days ago. So now we're also going to work on percent increase decrease, but specifically now we are working on percent error, the percent of error. So, for example, percent of error is the difference between an estimate and an exact answer. So when we are calculating for percent error, it's going to be very similar to what we did before, but the first thing we need to figure out is what was the amount of error, and then we're going to divide that by the actual amount. So for example, Ben estimates it is 10 feet from his couch to his kitchen. The actual distance is 12 feet. So the percent of error is calculated by taking the amount of error. Well, the difference between 12 and 10 is 2. So the error was 2 feet. The actual distance was 12 feet. So then we're going to go to our calculator and we're going to do 2 divided by 12. And your calculator says 0.16666, repeating. But this is the percent. So now what I'm going to do is take that decimal and slide it 2 places to the right. So my percent error would be 16.6 repeating percent error. You have to label it with all of that. Kevin believes there are approximately 80 puppies at the Humane Society. Not the human, the humane. He calls and finds out there are really 102 puppies. What is Kevin's percent of error? So the first thing we need to do is find the difference between 102 and 80. So I'm going to come over here. Actually, we can just do our calculator because you guys are using calculators now. So you can do 102 minus 80 is the difference of 22. So that number goes on the top of the fraction bar. Difference of 22 puppies, and then the actual amount of puppies was 102. So now I'm going to go to my calculator and do 22 divided by 102, and my calculator says 0.2156. We're going to round to the nearest tenth. So I'm going to take my decimal and slide it 2 places to the right. If I'm rounding to the nearest tenth, then I have to look at the 6 right here. That 6 tells me to round the 5 up. So the percent error would be 21 and 0.6% error. That would be your final answer, 21 and 0.6% error. Eric estimates that a baby weighs 8 pounds. But really she weighs 9 pounds. What is his percent of error? Step 1, find the difference between his estimate and the actual weight. So 9 minus 8 is 1. So the difference, the amount of error was 1 pound. The actual weight was 9 pounds. So now we're going to do 1 divided by 9. Which says 0.111111, repeating. We have to convert our decimal to a percent. So I am going to slide my decimal 2 places to the right. So my answer would say 11 and 1/10 repeating percent error. That's our final answer. All right, so what about this? Find the percent of change from 3/5 to 4/5. Percent of change, we're going to do the same thing. So we're looking at 3/5 to 4/5. Well, the difference between those two numbers is 1/5. And the original amount is 3/5. So percent of change is the difference divided by the original number. So now I'm going to come over here and know what I do with fractions, 1/5 divided by 3/5, multiply by the reciprocal, so keep, switch, flip, cross cancel, and multiply. Now, remember, we're supposed to give our answer in the percent, not a fraction. So now I'm going to go to my calculator and divide 1 by 3. Numerator divided by denominator is 0.3 repeating. So, trying to find a spot to write here. So 0.333, etc., would be 33.3 repeating percent increase. Remember, this is going back to increase, decrease. So if it goes from 3/5 up to 4/5, it's increasing by 1/3. Find the percent of change from 1/8 to 3/8. So the difference between those two numbers is 2/8. And the original amount was 1/8. And remember, this fraction bar means to divide. So we're going to do 2/8 divided by 1/8. Keep, change, flip. Cross cancel your 8s, and that's 2. Now remember the number 2, if we added a decimal and moved that decimal twice to the right, we'd have to add 2 zeros. So the number 2 is equal to 200%. So my final answer would say 200% increase. So again, this number is going up from 1/8 to 3/8. All right, last problem. Josh claims that a change from 30 to 60 is a 100% increase. But a change from 60 to 30 is only a 50% decrease. Is Josh correct? Well, we're going to have to solve these two problems. Since I have two problems to solve, I'm going to divide my workspace in half. So over here, I'm going to solve for 30 to 60. And over here, I'm going to solve for 60 to 30. So the first thing to do is to find the difference between the two numbers. So focusing on the 30 to 60, the difference between those two numbers is 30, and the original amount was 30. Well, we know 30 divided by 30 is 1, and that equals a 100% increase if we're going from 30 up to 60. So far, Josh is correct. 30 to 60 is a 100% increase. So let's calculate for the other one. First step, find the difference between the two numbers. The difference between 60 and 30 is 30, divided by the original number, which was 60. So 30 divided by 60 is 0.5, which is 50%. And going from 60 to 30 is a decrease. Yes. Josh is correct, and we can look at Ms. Jardine's math to show why he is correct. All righty, that's all, folks. See you tomorrow.